Can everyone hear me? Great. So first of all, sorry for the confusion to the schedule. Actually, I live in Korea for 30 years, and I spent 30 minutes to find the correct room. The schedule must be changed upright. Okay, and today I'm talking about how to accelerate computation step, and I believe most speakers mentioned their employees, but I'm currently currently a member of the Korea Ceph User Group, so just a few minutes by advertisement. So what Korea Ceph User Group is just people to have interest in Ceph and various technologies. So we are not limiting to their technical skills. Not everyone needs to be a good C++ programmer. Simple typical users or people just having interest in Ceph or newcomers, everyone are welcome to take activity in Ceph user groups. Yeah. So we have a regular meeting, and we share and we study and we gather information about how Ceph works and how to use it. And so actually every members are pretty shy, so. So before going further, how many people of you guys have ever treat a large set of data? Do you ever are familiar with SQL? Okay, great. So before digging further, what is Ceph? Ceph is open source distributed system. It's reliable and stable and designed for any organization and unified storage. But actually, you all guys know what Ceph is, right? That's why you're at it here. And we are here to use Ceph as a data storage, and so how to get our data from Ceph. So each one you imagine, we store data to Ceph, like this one typical example I generated from AWS Remote. So this is a typical CSV file, the comma separated. As you see, there are 4 columns: name, phone number, city, and occupation. So most people are working for AWS because I get this example from AWS blog. But anyway, what if we get our entire data set of this database? The data should be pretty large. It can be a megabyte or gigabyte. Or if we get our data for all around the world, it can be pretty large. And it can be very cost effective. It can the size will be very large and it affect the performance of Ceph. So, for example, what most database users don't care about the entire data set. They want a very specific kind of data set. For example, as you see, there's a phone number person named Jane who works in Chicago. Let's try to gather this data from SQL. So I think most people in here understand what this simple SQL is. It just find the entire data set with which the column name is same with character JANE. So, and what it actually happened is, he first tried, because typical storage doesn't understand what data set is. It's just many data set files are just a collection of bytes. So if we first gather every byte from the storage, and then the application tries to find, parse the data, and vector the data, and return the result. So between the left side and right side, the entire data set must be transferred. If the data set is 10 gigabyte, the 10 gigabyte must be transferred from Ceph to application. On 100 gigabyte or 1 terabyte, every application must be moved, and it costs a lot of bandwidth per network. And not only network, because data must be parsed every time, it costs a lot of CPU usage and memory usage to application. But what if we change the order? What if the object storage first filter the data, as you see, this SQL is very simple. There's no such thing as join or no such thing as currency estimation, no such thing as find unit. You just try to find chain. It's a very sequential search. So let's first read data from the first to end, finding just record which the column name is Jane, and then it moves it to application. So in the application side, because this SQL is very simple, there's nothing to do. And most of the time, how many records will move from Ceph to use search application? Typically, a few records, and if the name is unique, only one record will move from the Ceph to application, whether the data is large or small. And this technique is called predicate pushdown because application can estimate the cost between every process and then try to move large transformation into bottom layer. So for example, if Ceph can calculate the SQL, the user application can send the SQL back to the lower layer, the Ceph layer, because this kind of filtering can be very effective. The filtering is happening in the bottom side layer. And similarly, there are several other techniques like this. If file format support the predicate pushdown, we can do the same thing to predicate, same thing to file format like Parquet or ORC. And this idea is not my unique idea, and so actually AWS tried to implement it. So what AWS called it is S3 select. So S3 is AWS's own implementation of object storage, and they implement this feature, and they also create the API, and they also implement the core implementing into SDK. So this is an example of Python SDK. Actually, I'm not sure everyone are familiar with Python, but the C++ example code is too long to show, and actually most of the things are not important. So the only thing that you need to find out is the red line. We just simply send the SQL string, send it to object storage, and object storage can read it, and object storage can evaluate it to database, to data file. So, but it doesn't mean that S3 select can do any kind of SQL, because some SQL requires a large amount of memory. So S3 select only supports very few limited subset of SQL. And this is very effective for some large data sets and some application that can be run on S3, like Trino support these kind of features. Okay, now so the problem is how to implement it. There comes the, I'm now trying to introduce the Apache Arrow project. Apache Arrow is a cross-language developed platform for in-memory analytics. It's a developed platform for building very high-performance applications that process and transport a large data set. So it is designed to both improve the performance of analytical algorithms, like finding counted rows, and it can be very efficient to move the data from one source to another, whether your programming language is and it okay, sorry. Yeah, it can be moved data from one system to different system, and it can be moved data from one programming language platform to different programming language platform, like it's from JVM to Python or PyTorch. And okay, sorry. The critical component of Apache Arrow is in memory. Yeah, so it is in memory. It's not optimized for writing to disk, but it's in memory and it's a columnar format. So as you see, I'm not sure you guys can see, but actually you guys can distinguish color. So there are three columns. The blue one is session ID, and green one is timestamp, and the red one is source IP. So the left side is traditional memory format. It stores data for every row. But the right side is how Arrow stores the data. So because Arrow is not only in memory, but it's a columnar storage. It's gather data into every block of columns. So this allows computation routines and execution engines to maximize their efficiency. For example, because every data are in same columns, you can leverage a vectorizer like using SIMD or using Neon in AMD, Neon in ARM architecture, and this will provide additional performance boost. So, and I think you guys are thinking about so why memory columnar format must be standard. And here's another great reason. So before the error, every database and language has to implement on internal data format. So you can think it's like an STD vector or STD, but everyone has to implement their own format. So and everyone, because everyone implement their own format and it's non-standard, it's very crucial to send one data to another data. For example, what we send, as you see, there are 4 light blue at the upper side and 4 dark blue at the bottom side. So bottom side is, you can think it as storage layers. So what if we want to send data from CUDO to Spark? We should, the first CUDO should read the entire data, and then it should serialize data that Spark can read, and Spark receive the data, and Spark must be discharged data. So after this Spark implement support for CUDO, what about Spark wants to implement support for HBase? Spark must implement the same thing to HBase, because HBase is using different format. But after using Arrow, this is what Arrow score is. This is not currently happening right now, but Arrows in memory column data format is an out-of-the-box solution to these problems. So systems that use or support Arrow can transfer data between them and later, or even if they are in the same process, it can be of no cost. Moreover, they don't need to implement custom connectors for every other system. So for example, there are 4 storage layers, and if you want to add 1 more storage layer, and the storage layer is support Arrow memory format, and the entire ecosystem can adopt that storage layer. So on top of these savings, standardized memory format specialists reuse of libraries of algorithms across languages. For example, what the standardized memory buffer means, if someone tries to implement vectorized calculation on the Arrow memory buffer, then the other implementation can also reuse the existing implementation. So this will grammatically reduce the cost to implement new database system.
지금 전체적으로 방송이 안 되고 있다고 해서요. 마이크 사용은 힘들 것 같습니다. 알겠죠? 약간 건물 이슈인 것 같습니다.
Arrow data set is so to go further. What I can say is there are three things they first implement three data in Ceph, and they use Arrow as the data access API. The third thing that I didn't mention is there's bar format in Parquet. So okay, I don't already write it. Just recognize enough to understand about Parquet. Parquet is very is bar format designed for very storing efficient to store and accessing data. But, how many of you guys ever using Parquet or version system? Okay, okay. Don't worry. I can explain it. So Parquet. Parquet. The architecture of Parquet is very similar to memory domain of Arrow. So Parquet is also columnar storage function. So it creates every row group in every block, and it also has metadata as the footer. So for example, if the application tries to find a row with name, the application doesn't need to scan entire files, but it can just first scan the metadata and check if the name is not the application has it. Also, Parquet has some more optimization, like if the user wants to query data on age, but age is over 100, and if the row group has only age between 10 and 70, then application doesn't need to scan it. It can just scan the metadata and find the settings and skip. Anyway, Parquet is one of the very rare files when I use nowadays, and the problem is Parquet stores file format in its own layer. So for example, let's say our first row group is 130 megabytes, and application tries to retrieve data for every 128 megabytes. So it's just 2 megabytes more, but to retrieve entire one row group, the application must try to gather 2 blocks. So one of the techniques to make it more efficient is to regularize by adding padding to every row group. So user doesn't need to get split part of the row. Yeah, and this is one of the actual examples. So actually, the left side is one large ABC Parquet file. The Parquet file typically has extension named .Parquet, but to optimize it, there are two Parquet files. So two Parquet file has where aligned file, and the other technique is they put additional index files. So you don't need to scan every file's metadata, only index file makes it much better. So this is actual architecture in Ceph Days. Now you can find the actual. I talked for more than 20 minutes, and now you find out this very well-known words like OSD. You guys are the OSD, right? So this is how Skygen actually works with Skygen. It's all dependent to using Ceph CLSS. To use the Skygen, you must the Skygen. Create a CLSS script, and you must deploy it and try that to cut the OS server. Try also create additional Rusty database. This additional Rusty database trigger additional table registration. So it's independent from steps or table registration. And when user try to get start with first find the Rusty database and try to get an upgrade from 5 now. You can use using Apache Arrow. And so this is a very simple example. Yeah, actually, I cut the line because it's too long. So, and it looks very complicated. So it's never done. So as you see, the first few lines, I just define the string. Do you see? And I also strict using include lines, but as you see, Skyhu Firefly and Mac will create its own interface, and this will create the function, right? And then Skyhu here will read and find it. Okay, I'll post some lines and script, but just ignore it because they're not right. So, you see? In order to use it correctly, you must define schema. So in this schema, line 4 and 5, it's just a very simple schema. It just has two columns. One is payment type. Oh, the mic is working. Great. So it uses two columns. One is payment type with the integer type, and another is vendor ID with the same type, integer type. And it will inspect the data. And it tries to add additional filters. For example, in this example, it tries to filter the payment type is easily number 2. This is the line here, CP decorator, and it will send to Ceph object storage. And if everything goes well, user application will see the actual database, which has payment types equal to 2 in the standard app. So, yeah, it's 3 pages, but I think it's quite simple because yeah, Skyhu SDK will do almost everything. And if you try to see deeper, you find out there's only one line that has a matching with Skyhu, because all other lines are aligned with Apache Arrow. So that's the power of the standard. So just using Apache Arrow SDK and actual Skyhu SDK is doing very few things, and user can easily port existing Apache Arrow application into application using Skyhu. And another great thing is Skyhu was first an independent project, but now Skyhu is merged in Apache Arrow project, so it's managed in Apache Foundation. And but because we are creating Ceph Days, let's go back to Ceph. Actually, Ceph also has this feature. So have anyone tried to build Ceph? Okay, and if you guys try to build Ceph, and your guys are actually most of the time build Apache Arrow too, because Ceph project in CMake files also have some C files to gather Apache Arrow source and build it. The reason is Ceph also has integration for S3 Select. So unless if you guys are disabling Ceph Rados Gateway, most of the times you guys will also build S3 Select. And it's creating it exists in different library in Ceph S3 Select, and S3 Select projects are actually using Apache Arrow, but current Ceph implementation is using only few parts of the Apache Arrow. For example, unlike using Apache Arrow directly, this Ceph S3 Select also implement its own SQL parser independently. And so, if I remember correctly, S3 Select project currently only use Apache Arrow to parsing Parquet file, and that's it. So I think there's a few more rooms to improve it. So yes, I think we are already out of time. So I mentioned some future work. The first thing is there's a project named D3N in Ceph. I'm not sure it can be used well. But anyway, it's merged in currently Ceph code base, and it's called the reason it's called D3N is it's a data center, data delivery network. So there are 3 D and 1 N. So it uses high-speed storage, such as NVMe flash or DRAM, to cache data set on the access side. So if you enable D3N, try to get the same emoji multiple times, but it doesn't affect performance a lot. Instead, you must use additional caching node, like storage or using a Redis cluster. But it seems this range doesn't work well with S3 select. And actually, I didn't write in this. I didn't mention it slide on, but actually, it seems there's a new project named diff4n, and diff4n try to solve the problems I mentioned, like fast caching, but also implement on top of Apache Arrow. And yeah, it would be great if I can describe some more about diff4n, but I'm unable to find any more materials in describing diff4n, so I just mentioned this project. And the other thing is, actually, AWS is the pioneer to transforming data in object storage. But yeah, I just find out that Amazon AWS tried to seize this project. So as you see, this year, July 25, starting from this year, 2025, new users are unable to use this new feature. So the Amazon S3 project is the feature is we are not sure what to do. And the third thing is actually Redis Gateway implement almost every features of AWS 3. But if AWS if the AWS tries to cease and no longer supporting S3 Select API, then why should we try to follow their steps? For example, we can use better API for S3 Select. Or if it's no longer S3 Select, it can be Ceph Select or anything else. And for that thing, we can use better protocol. For example, Apache Arrow also provide better API to send a large amount of data from one source to other, which is called Arrow Flight SQL. Maybe we can adopt Arrow Flight SQL into Redis Gateway. So yeah, I think there's lots of things to do. Or maybe like I said, using GPU or using S8 to calculate data. So yeah, that's all what I provide. Have any questions?